Lord Kelvin, born William Thomson, was one of the greatest scientists and engineers of the 19th century. He made groundbreaking contributions to physics, mathematics, engineering, and thermodynamics. His work laid the foundation for modern science and technology, particularly in the study of heat, electricity, and temperature measurement. The SI unit of absolute temperature, the Kelvin, K, is named in his honor. William Thomson was born on June 26, 1824, in Belfast. His father, James Thomson, was a respected mathematics professor who encouraged his son's education from an early age. When William was 8 years old, his family moved to Glasgow after his father accepted a teaching position at University of Glasgow. William entered the university at the remarkably young age of 10 and showed exceptional talent in mathematics and science. Later, he studied at University of Cambridge, where he excelled in mathematics and graduated with high honors. At just 22 years old, he became professor of natural philosophy, physics, at the University of Glasgow, a position he held for more than 50 years. Scientific contributions: development of the Kelvin temperature. Scale: Lord. Kelvin's most famous achievement was developing the absolute temperature scale, now known as the Kelvin scale. Unlike the Celsius scale, the Kelvin scale begins at absolute zero Kelvin, the theoretical temperature at which all molecular motion stops. Key facts: 0 Kelvin equals minus 273.15 degrees Celsius. Water freezes at 273.15 Kelvin. Water boils at 373.15 Kelvin. Today, the Kelvin scale is the standard temperature scale used in scientific research around the world. Contributions to thermodynamics. Lord Kelvin was one of the founders of the science of thermodynamics, which studies heat and energy. His important contributions include explaining the relationship between heat and mechanical work, helping develop the second law of thermodynamics, demonstrating that not all heat can be converted into useful work, introducing the concept of absolute temperature. These ideas became essential in the design of engines, refrigerators, and power plants. Electrical engineering. Lord Kelvin made significant advances in electricity by designing precise electrical measuring instruments, improving electrical standards and measurement techniques, developing sensitive galvanometers used for detecting electric currents. His instruments greatly improved scientific experiments and engineering practice. The transatlantic telegraph cable. One of Lord Kelvin's greatest engineering achievements was helping build the first successful transatlantic telegraph cable connecting United Kingdom and United States. He solved technical problems involving long-distance electrical signals, designed sensitive receiving equipment, improved cable communication across the Atlantic Ocean. For these contributions, he was knighted and later elevated to the peerage as Lord Kelvin, taking his title from the River Kelvin, which flows near the University of Glasgow. Some of Lord Kelvin's most influential works include On the Dynamical Theory of Heat, 1851. Explained the Principles of Heat and Thermodynamics. Treatise on Natural Philosophy, 1867. Co-authored with Peter Guthrie Tait. This became one of the most important physics textbooks of the 19th century. Numerous scientific papers on electricity, magnetism, elasticity, and mathematical physics. He published more than 600 scientific papers during his lifetime. Lord Kelvin received many prestigious honors, including President of the Royal Society, 1890 to 1895. Knighted in 1866 for his work on the transatlantic telegraph cable. Raised to the peerage as Baron Kelvin in 1892. The SI unit of thermodynamic temperature, the Kelvin, K, was named in his honor. Lord Kelvin's work transformed physics and engineering. His theories continue to influence physics, mechanical engineering, electrical engineering, materials science, space science, climate science. Scientists and engineers still use the Kelvin scale and many principles that he helped establish. Lord Kelvin died on December 17, 1907, in Largs at the age of 83. He was buried in Westminster Abbey near the grave of Isaac Newton, reflecting his immense contributions to science. Lord Kelvin was a pioneering physicist, mathematician, and engineer whose work fundamentally shaped modern science. His development of the Kelvin temperature scale, advances in thermodynamics, innovations in electrical engineering, and contributions to the transatlantic telegraph made him one of the most influential scientists in history. His discoveries continue to support scientific research and technological innovation around the world.